All right, so here we are looking at email in Python. Well, let's look at what email is anyway. So email, text messaging, Facebook, whatever, anytime you're sending something one person to another, they all work on a similar paradigm, meaning high level, they work the same. It's like going to the post office, but how many people go to the post office anymore? But just pretend you know how to mail letters. So you address your envelope, you put your stamp on it, which is what Bob's doing right here. He sends it to the post office here in Scottsbluff. Well, the Scottsbluff post office sends it to, say I'm sending a letter to my niece in Sioux Falls, which I just did. It goes to her post office, and then it goes to her mailbox. Text messages, all that sort of stuff. Discord, it's all the same kind of a thing. It's stored and then it's transferred. Sometimes it's stored and transferred internally. Like if I email everybody in the class, the email message goes from me to you and it stays in the server and just goes from one person to another. If I'm emailing outside, then it goes from here to here. Like Discord has messaging, but it's all internal, but it's the same idea. You send your message to the post office. It just happens that everybody's in the same post office. All right, so what happens here? SMTP is the acronym for Simple Mail Transport Protocol. This protocol was one of the first protocols invented, which is why they call it simple. It had no encryption. It had very little of anything. You could read the messages, plain text. Well, that's not such a good thing, is it? If I can install a packet sniffer on your network somehow with a backdoor Trojan horse thing, I can read all your email. So they decided to fix that. So this between here and here is now encrypted. So it's called SMTP. The word for it now is SMTPS or secure SMTP, meaning everything is encrypted from one end to the other. I can't think of any mail servers that do anything by plain text anymore. All right, so sends it to, in this case, Gmail, right? We're sending our information from our Python program to Gmail. So that's our post office. That post office sends it to whatever address you send it to, Hotmail, Yahoo, WNCC.edu. We're done sending. SMTP is used to send from you to the server, between servers. But when we retrieve it, forget the POP3 because I can't think of the last time I used POP3. IMAP, Internet Messaging Something Protocol. What that does is you don't actually take the message off the server to your computer, you're reading the message on the server. But you're in effect using a user agent, like on your phone. If you look at your Gmail on your phone, there's a temporary copy on your phone, but it's really synchronizing itself with what's on the Gmail server. So maybe synchronization is a better term. It used to be that we would download the message from there to here, that would be taken off the server and only be on your computer, but that's been obsolete for I don't know how many years now. You can still do POP3 on Gmail, but I haven't used that either for years. I almost always use this. Well, if I'm retrieving, huh?
How many still have a Hotmail?
No, Hotmail uses this too, IMAP. Yeah, everybody uses IMAP, a form of IMAP. Microsoft's Hotmail calls it ActiveSync or something, but it's the same thing. I have a Hotmail account because I've had it for years. William Loring at hotmail.com. I've had that for I don't know, since almost the beginning of the internet. Just like William A. Loring at gmail.com. I've had that forever. And because I'm very careful where I use it, get no spam hardly at all. That's how you get rid of spam. So this goes through what's going on, and that's what we're going to do. And in my case, I use Outlook quite a bit. And it doesn't really fetch messages. It reads the messages and synchronizes with the server, because that's why you can look at your phone. You can go to the web. You can use an Outlook client on your computer. You are looking at the same messages. They're the same everywhere because you're reading what's stored on the server. So your email is stored for WNCC at Microsoft. So that's why you can get it with any device anywhere, which is better than getting it once and only having it on one device. Boy, it's been a long time since I've even thought about POP. So, oh, look at here. We have eHello. We had hello first, but then eHello is like enhanced hello, which is like, if I'm going to go to the post office, don't you usually say hello to the postmaster? Yeah, that's what that's like. It's like saying, hello, I want to send a message. And then we go through all this stuff. We have little things that say, this is the like, I can accept a message from you. And then you say, okay, I have a message from, and the server says, yep, this is okay. I can send a message to that person because it does checks and stuff. Says, yep, we're good. This is where I'm sending it to. Okay, that's good. Here's, I'm ready to send. And then I send the message. And all this happens. We don't have to like split it line by line. And then I accept the message for delivery. And then the session's terminated and we close it. See, that's just what happens every time you go to the post office, isn't it? Yeah, but this happens like that, and it's electronic. So the first thing you want to do is open your browser, access your Gmail account. And I discovered yesterday with somebody, you can't use the wncc.edu email account because it's like restricted a little bit unless somebody's gotten it to work. So you want to use like a regular Gmail account here. I don't think it works. I should probably put that in here. But somebody was having trouble and that was my only guess. So I'm just going to say, don't use your wncc.edu account unless you've used it and it works and I have another issue because I haven't heard back from the student yet. Because it said, this is not available. Because you have to turn this on or set this up. You have to enable two-step verification. Well, we can't do two-step verification with Python. So what we do is there's a special app passwords section where you set a password that does not change. I'm there. That's my account I use to send stuff. Oh, maybe I don't. No, that is the one that I do. Why is it telling me I can't do that? Oh, they moved the setting. That's what that means. I have to find the new link. That's the problem. I bet, is that the setting's been moved. Uh-oh. Are you gonna, do you think you should move to Florida? Oh, she missed it.
Yeah, she not heard it yet.
Okay, just good to know. The Magic 8, oh, we need to test with the Magic 8 Ball, don't we? Okay, so that's probably not it. I need to change my links. Let me pause for a moment. So we want a file. Whoops, let me go to the actual code file. The reason for having all your authentication-y stuff in one file is look at all these different little programs I've done to experiment with emailing. Well, if I don't really want to put my credentials into every single file, because that's just like redundancy. So I put them in this single file and I import them. SMTP without security uses port 25. Secure SMTP or SMTPS uses either 587 or 465. And you can find that out by researching what SMTP port does Gmail use. So to make sure I'm not lying, what SMTP ports does Gmail use? So this is for SSL encryption. It's deprecated. I didn't know that. Yeah, TLS, that's, oh, I better put that in there because that's interesting. Yeah. All email clients, as far as I know, support 587. In fact, that's the first one I saw. But maybe they migrated SSL over to here and then used TLS. Anyway, TLS is our best encryption. So I need to put that right here. And I'll format later, but that's good information to know. TLS, transport layer security, is more secure than SSL. SSL is the first thing we did to encrypt information. So it's been around for a very long time. Then we went to TLS. So secure SMTP port uses TLS, which means transport layer security. So which layer is the transport layer? Layer 1 is
physical.
Physical. It's the lights. It's the electrical connection. It's the wireless stuff. It's the physical thing that connects to the network. Your wireless card is part of the physical layer. Many devices go further up the network stack. So layer 2 is
Hardware is,
Data link.
where's
MAC address.
MAC address?
Yeah, MAC address, data link. That's where the pulses of whatever physical medium are translated into bits and bytes for the computer to understand. That's where our MAC addresses live. Layer 3 is the,
Transport layer.
well, layer 3 is not the transport layer yet, because MAC addresses only work in a local network. If I want to get to Google, I can't contact Google by using my MAC address only. I need a routing layer that's a logical addresses. So layer 3 is the routing IP address layer. So for instance, a switch is what's called a layer 2 device because it only reads the MAC address and says, oh, this packet goes over there, and it sends it. Routers look at the IP address and say, oh, you want to go to google.com. Let me send you there. Now, Sean, layer 4, transport layer. That's where TLS operates. So it operates at the part where the transport layer is like where we slice things apart into little packets. Above that is layer 5, 6, and 7, which you can loosely think of as the application layer. That's the layer where the program doesn't live, but that's the layer where the program talks to the network stack. And it's quite often referred to as a stack because it's in layers. We have a stack of pancakes. So SSL operates at the application layer, which means it's encrypting the whole thing once, and then it gets split. Well, they discovered it was better to encrypt it after it's split. You can do better encryption, apparently. That's as far as I can go with that one. So port 5A7 is the TLS port. We need a login. We need your app password you generated. And that way also I can put this in an assignment and not have to give away my secret beans either. And I can have another one that actually works and lets my email work. All right, so let's look at how this works. I think it's just this one. Oh yeah, yep. So guess what? Python has libraries for everything. You want to manage the space shuttle, manage this International Space Station, import ISS, and then you can tell it where to go, right? All right, so we manage communication with SMT server with SMTP lib. Well, that totally makes sense, SMTP library. We also want to be able, there's a couple different ways to do it. I like doing it with the email message thing. You can do it kind of in your own raw format. I just like this because it's, I just like it because I've used it. So from the email library and the message part of that library, we're importing the email message class. Well, email from me, waluring@gmail.com. If I send it to more than one address, I just have to separate it by a comma. If I only want one address, I take out, when you only have one address, you do not need a comma. Comma is needed if you want more than one address. So if I put another comma, I could send it to more people. So I could spam people with this, couldn't I? Well, we're going to get to that project where we learn how to spam people with like a really like spammy place that we can use for free.
Using threads.
Yeah, we'll use threads, but in this case, there's a place I use in, I think it's in Europe. It's called Sendinblue or something like that. You can set up a little account and then it disguises your email address and sends it if it comes from someplace else. And then you can do that to spam people. It's for email marketing, right? All right. So
Don't
we,
forget your comma.
oh yeah, it would crash and burn, wouldn't it? All right, thank you. So we need a subject, email from Python email program, and content. So each of these pieces gets placed into our message object. So we are setting this from property to our email from. Our set content, there's our content, our subject property, subject, email destination, yeah. So I just think that makes sense. You set up your stuff here, create the message object, you use this to make it easy to do, and now you're ready to send your message. Message contains all this information ready to roll out the door. Now we send it. Oh my goodness. Well, we use the try block because things can blow up, right? That's the reason I put that in there. Because if it doesn't get sent, well, we want to know if there was an exception, that something went wrong. All right, so we use the SMTP liblibrary.smtp. And for those of you in computer science, you should recognize what the SMTP thing is doing. What are we creating? We're using the with context manager. We're creating an SMTP object. And at the end of this, and when we exit, it gets thrown away automatically. We don't have to create it and delete it or anything. So with this, we're doing all these things. These are parameters that are being passed into the init or init function, or as we're creating an object. Here is our object. So we're doing all that in one thing, and it's more succinct, or I'm not sure what to say. It automatically closes the connection. You don't have to say close the connection. It automatically gets rid of your
Yeah,
object and closes it for you.
we use weave.
With is really handy to use for files and data, especially databases, this kind of stuff. Because it creates the object, does its thing at the end, we're done. It gets rid of it. You don't have to do it manually. So that's a fairly advanced Python concept we don't get to until Intro to Computer Science and Computer Science 1. But that's what it's doing. It's like, with this suitcase, I can travel to Russia or wherever. No, I don't think I want to travel to Barcelona. Yes, much more fun than Russia. All right, so set debug level is something you do if you're having trouble communicating with a server and you want to find out, okay, what the heck is going on? Why is it failing? So I have it set to true right now because I want to see each little step as the communication happens. So you know how much goes on every time you send an email message. So we say our enhanced hello. We request a TTLS connection, which means we have to negotiate and say, hey, do you have a TLS connection? And if it doesn't, we're just going to say, okay, bye, we're not interested. Because we want TLS or nothing, because we're specifically saying TLS. This may have a fallback in the library, I don't know. No, it doesn't say there's a fallback on it. It just, yeah, it looks like it just says that. And then the guy says, oh, yes, I do TLS. Let's get together and have a conversation. So then after we've done that, once we're encrypted, then we log in with our credentials. So we're not passing our plain text credentials. And how do you suppose those credentials are passed? In this case, they're probably just encrypted. I don't know if they're hashed because the SMTP cert, well, they probably are. They probably are hashed because I've already got this account created on the server. So the hashes are being compared through, and they're encrypted at the same time. So is anybody going to get my email address and password? That's why social engineering is the big ethical hacking. Because I can talk you out of your password, or if you put in the name of your husband or oldest daughter, you know, I can get your password that way. It's much easier than like unscrambling all this. Then I say, okay, send me the message. And then we find out if it's successfully sent. Well, let's look at all the fun that goes on. And how fast it happened. Oh my gosh, look at all that. And each of these are going up and down the network stack. How many times as it goes across? I was talking about this in Networking Essentials, and it's just like, oh my gosh, look at all that stuff that happens. This is setting like the parameters of how we're going to communicate. I mean, the server is saying, this is what I can do. And then it says, at your service, I can do all these things. We're ready to start. And then we start. I don't remember where we exactly start. Yeah, somewhere in here we start.
There's the
And then,
hello.
excuse me,
The hello is a couple lines up.
the hello.
Yeah,
The EA silent,
right there.
right there. Oh. right
Oh,
there.
yeah, hello.
Oh, yeah.
It's saying hello to me. Notice it knows who I am. Because how can it know who I am? Well, my host name travels along. I'm not at the same IP address anymore, am I? So it's thinking my computer is an email server.
It says default mobile.
Right. That is the host address of my computer. not host address, the URL of my computer. And my computer is it an email server? In effect, I am sending SMTP email directly from my computer to Gmail, which is how it knows who I am. It thinks this address is ds10.dpod.local. The only reason we can get past a lot of the stuff where it would say, no, that's not going to work because you're a dpod.local and that doesn't exist on the internet, is because we have that app password that allows us to connect without, because actually in the real life, all that checking goes on. Oh, you're not a legitimate thing. Oh, you're coming from China. Oh, it does all kinds of checks and balances, but our app password lets us get past some of that. And then it's still at our service and we're logging in with stuff and we have authentication tokens and all kinds of things happening. And oh, finally we're authenticated after all that. Then it says, okay, here's my message. It's going to accept things and here goes my message. You know, look at how many times, yeah, here we are. There's my coming from, going to. So now it's in their post office, in the Gmail post office. And what would happen next? Well, their post office sends it to my post office and then I pick it up in my email.
And that's just the acknowledgement, right?
Yep, this is saying that I've sent data. And it says, what I'm doing when I send, let's go up to the beginning. Okay, we've authenticated, we've said that we're ready to go. I'm ready to get a message. And then I send the message to them, mail from me, blah, blah, blah. And it says, where does it say that it's actually been? So I guess receipt 2 is the part where it says, yep, got it. We're going to send that on. Yep, got it. We're going to send that on. Go ahead and send it. Go ahead and send it. And then it shows the plain text version of this. Well, does it matter if it's plain text at this point? It's encrypted. So we can, that's what encryption is for, is sending plain text stuff, because SMTP at the groundwork is designed for plain text messages. It wasn't designed to attach anything. It wasn't designed for encryption. All that's been added on over time because they found that was a need. And then after everything's been sent, we say, okay, I'm ready to quit, closing connection, return code is returning connection. If nothing failed at this point, this is going to come up. If it did fail, well, then it'll return an exception because our SMTP module wants a complete transaction. So one of the reasons this will fail is if you didn't get your app password set up right, or you're using just your Gmail password, which you can't use. It has to be that special app password. Pretty cool, huh?
Mhm.
Is that as far as I go with this one? I think that's as far as I need. Oh yeah, I have a screenshot. Yeah, that's all we need at this point. You see the whole thing and how it goes on and all that stuff took place how fast? When you know how networking works, all the packets that have to be sent back and forth and all the up and down for each router between here and Gmail and how fast did that happen? I could time it. I could put a little timer in there to find out, but it's just amazing how fast things happen, going up and down, being deciphered by everything in between us and there. Just in this room, I have to go through a switch and a router. Then the router has to go downstairs to a switch to another router. And then from that router, it finally gets to Allo, and then Allo has to carry it to Lincoln. And then it has to hop several times to get to Google and back again for each single packet, which means that my message might be broken up into several packets. Yeah, a lot of chatter going on. I think it's amazing that networks function